find x. You might have seen this before, and some child says here it is, and actually such out of box thinking is very useful for gate. Okay, we'll try to look at few examples in today's presentation. It is a very important topic, and we are also going to look at some examples and solve it during the class. So let's actually dive into the topics. Let's use a pen and paper. Let's start solving some questions. So I have some example over here to just add some spice. The teacher said, what is 2 plus 3? Some student replied 3 plus 2, and of course the teacher was like puzzled. He didn't know what to reply for a moment, and then the student added, because addition is commutative. Okay, couple of things to notice. It might look like a joke, but I brought it on for very important reasons. Notice that the student may not know 2 plus 3 is 5, but his answer is correct, first thing. And the student used a property of addition, which is commutative. He knew this plus 5 is commutative. Doesn't need to know 3 plus 2 is 5, but he can give a very correct answer, okay, which is 2 plus 3 is 3 plus 2. It's a smart answer, okay. We need this kind of answering, this kind of thinking for some gate questions. I will try to give examples, some examples in this video, okay. And to just to warm up in the mock test, this is not to offend anyone, this is for everyone to learn, okay. There are some type of questions called NAT, numerical answer type questions, right? What you are expected to enter is a number, is a numerical value. For example, the ratio between L1 and L2 is, let's say 4. Shouldn't enter 4:1. That's not a number. Similarly, 4 by 1. That is also not a number. And of course, there are many examples. We are all like creative, and the worst thing is, student might make this very silly mistake, and he might never even like catch it. Gives some automated test series, he gets an answer saying it's wrong. Okay, gives a gate exam, he says that question is wrong. He may not know it. So this example provides an energy of dash kilocalories. Say the answer is 7.3. You shouldn't enter 7.3 kcal. Okay, this is not a number anymore. Again, say the value of the integral is dash. The computer is expecting a number. So 1 is a number, minus 1.1 to 0.99 is a range. Okay, we shouldn't enter such answers. Okay, very silly mistakes to avoid. Some of you were making, so avoid it from now on. Okay. Okay, one more thing, because I missed a question in the chat. If there are questions, just stop me and go for it. Okay, that's the best way to catch everyone's attention. Chat is good to take polls and all that, but questions, stop me, go for it. This is related to that community example that we looked at. Can you all answer this as soon as possible? What is 1 plus 2 plus 3 till 50? Are you all like working it out? Can we have some responses, please? One to 75. Who is that? Satabisha. Okay. Actually, I did not calculate what this is, but I have 3 answers saying it's 1 to 75, so I think it is right. Satabisha, how did you find it? N and n plus 1 by 2. Okay. Okay, that's correct. If you remember the formula, it's very good. You found this answer. What do you do if you don't remember the formula? In the gate. Okay. So let's go to that. It turns out, a couple of centuries back, a student was sitting in an elementary school, and he was posed this very question that I posed you. What is 1 plus 2 plus 3 and all that 50? All students started counting 1 plus 2 and all that by hand. there was one smart student who noticed an interesting symmetry about the problem. Okay, he realized he takes 1, 2, 3 up to 50, writes them down again in the reverse order. Okay, then you notice 1 plus 50 is 51. Okay, 2 plus 49 is 51. 3 plus 48 is 51. All of these are 51 because of the symmetry. 50 plus 51 is 51. Okay, so we have 51 plus 51 plus 51. How many number of times? There are 50 such terms, 1 to 50, 50 terms. Okay, and notice this particular sum, there is double counting. 1 appears twice, 50 appears twice, 49 appears twice. So account for the double counting, you get 51 times 50 by 2, which is n times n plus 1 by 2. Okay, so that commutative example that I showed earlier might have looked like a simple joke, but these properties can be exploited. We'll try to look at more examples. Did you all agree? Did you all follow my argument over here? Some answers, please. Replies. Okay. Okay. Thank you. Okay. Thank you. Thank you very much. So the student actually who did that, I'm going to show him. Do you know who this is? Guesses, please. We don't have any guesses. Okay. So actually the student is one of the greatest mathematicians we ever know. His name is Gauss. Have you heard of him? Yes, Gauss was the student, and in fact this was the answer that he gave, the explanation that I explained before. And okay, commutative is not, that special property, it's not going to show up in all GATE exams, but this example is again important because many GATE questions, you don't need to know what is 2 plus 3, what is 3 plus 2. You need to know the properties that all these functions or these operators are satisfying. I'm going to give an example. Okay, you might have come across this question: the eigenvalues of a 3 by 3 non-singular matrix P, okay, or 1, 2, 3, the trace of a matrix is P inverse is dash. Notice this matrix is not given, like 2 plus 3 is 5. This matrix is 5 is not given. This matrix is not given. All they are saying is that it's a non-singular matrix. It has eigenvalues 1, 2, and 3. Then they ask the trace of matrix P inverse. Okay, and this question they ask it because this eigenvalues satisfy certain properties. Okay, in this case the trace is sum of the eigenvalues lambda 1 plus lambda 2 plus lambda 3. Okay, that's a trace, and the eigenvalues of P and P inverse are related. If these are the eigenvalues of P inverse would be 1 by lambda 1 plus 1 by lambda 2 plus 1 by lambda 3, right? So we know eigenvalues satisfy this property. We don't need to know what this matrix is. If we know this particular, we can go ahead and answer this question. In GATE, these type of questions are very typical, okay, specifically from linear algebra. And can we have some now guesses on what other type of rephrasing could happen here? This example, let's say the trace of a matrix is P inverse. Instead of that, can you give some other alternatives that could be asked? Yes, please say it. And also tell your name so that we all know. Determinant of the matrix. Who is that, by the way? Thank you. So determinant of a matrix. That's correct. And then what else? Yes, please. Yeah, determinant is multiplication of lambdas. So again, we can find that. That is fine. Someone had a question. Who is that? Exactly. Yes. There you have to know what the definition of a skew symmetric matrix is, right? If you know the definition, you don't need to know. You need to know the definition to answer that question. Yeah, that's a nice example on what I'm trying to say. Okay, we have some answer here. P square. We can find the eigenvalues of P square. What are the eigenvalues of P square, by the way? If eigenvalues of P is say lambda 1, lambda 2, lambda 3, what are the eigenvalues of p square. Yes, lambda 1 square, lambda 2 square, lambda 3 square. In fact, lambda 3 square. Okay. In fact, this applies to p power n, and there are a couple of other related matrices to p, family of p, for which eigenvalue based relations are there. If you know those properties, you can write this answer in 5-10 seconds. You are done. 1 plus 1 by 2 plus 1 by 3, you do it, you get like I think in this case a mark. Yes, 11 by 6. Yeah, you get that. You move on to the next question. Okay, this is what you are supposed to do in the gate. There will be many questions like this. This is a type of questions that IIT professors who set the gate paper, they like to ask. Okay, and now let's also slightly get into this aptitude part. I have shared a question, so take a minute. Okay, think about an answer, and then we'll make the class open and let's all discuss. Take a minute to answer this question. So we have 8 1 rupee coins and a weighing balance, which means you can, weighing balance, you know what I mean, right? One of the coins is heavier than the others. What is the minimum number of weighings required to identify the heavier coin? Take a minute and we'll openly discuss once you all have tried it. Okay, and type in the answers, say the answers as you figure it out. Okay, let's wait for others to answer, because others might have an opportunity to learn. Okay. No need to be sorry. First of all, you gave a very nice answer, and I encourage students to answer. It's okay to make mistakes. I might make mistakes every now and then. I try to learn. I try to correct it from the next time. There are no silly questions. There are no silly answers. And I think you gave a nice answer. Okay, I will ask you to explain once everyone has tried it. Don't feel sorry for that. Okay, I want you to come and give nice answers. It's okay. Even if it's wrong, it's fine. Let's have a nice discussion. Let's learn from it. Okay, so we have a couple of answers in the chat. Okay, minimum is 2. We have one answer. Then 2 students think minimum is 2. Then 2 students think minimum number of weighings is 3. Can you all quickly try this? So the more you work out, the only way to build muscles is when you do the exercise. So by default, by attending the class, by default you have an opportunity to practice. Okay, how many of you say it's 3? Raise your hands, please. We have an answer saying 7. Okay, we'll get there. Thanks for trying that. How many of you say it's 3? Okay, I have one hand that has risen. It's okay to use names, right? We are all here for learning. Okay, if you make mistakes, there is nothing personal. Objective is for all of us to learn. Okay, so if I were to use names, you make a mistake and all that, don't take it personally. Objective is for us to learn. Okay, I had one person raising their hand for saying it's 3. Okay, thank you. How many of you think it's 2? Okay, Satabisha already said it's 2. Okay, and Mihir says it's 2. Thank you. Others, please, at least give me some number. I'm going to call out your names. So at least in the chat we have 3 answers: 2, 3, 7. Okay, you don't really need 7. The answer that's a trap is here is 3. Okay, that's a trap. The correct answer is 2. Okay, now let's give Satabisha a chance. She has been waiting to explain why this is the case. Please. Okay, thanks Satabisha. Yes, you are correct. Your explanation is correct. So the correct answer is 2. So one of the reasons to think it might be 7 is because you take 2 coins at a time and weigh it. See which one is higher, lower in a pan, right? In that way you will have to do 7 weighings to find which one is higher. Of course, we need to start optimizing. You got it? Okay. So if you do it like 2 coins at a time, of course you will need like 7 number of weighings. Okay, but things could be optimized. Things could be done more efficiently. how about we do 3 coins at a time? Okay, and in fact, can we do more than 3? The answer is yes. Before I explain that, the trick to getting the intuition behind this is, so instead of 8 1 rupee coins, let's say we had like 3 1 rupee coins. Okay, coin 1, coin 2, coin 3, just 3 coins. Simpler problem. How many weighings do we need to identify the heavier one? Say one of this is heavier. Let's take 2 of them. Let's weigh them. Okay. If one of them is heavier, we can find it, correct? In one weighing. If the pan remains equal, okay, if 1 and 2 are equal, which one is the heaviest coin here? 3. Without weighing, we can say 3 is the heaviest coin. So do one weighing, we can identify the heaviest coin. Heaviest coin could be 1, 2 or 3, whichever the case it is. Do one weighing, we can say which is the heaviest coin, because weighing 1 and 2 gives you information on 3. That's the intuition behind optimizing this number of weighings. Now let's look at our question. We have like 8 1 rupee coins. So the first strategy is, instead of weighing one coin at a time, put them in a batch. Put them in a batch and see if we could weigh them. Okay. So the optimal way to do that is 3 3 2 split. Okay. So split the 8 coins into 3 and 2. Take this and this together and weigh them. Okay. If the heavier coin is, say, in this list, this pan will go down. Okay. We know the heaviest in this 3. Then in one more weighing, we can say which one it is based on this logic. Agreed? Some hands, please. Okay. Then some students might ask, what if the heaviest coin is not in this 3? It is actually in the 2 coins that we left out in the first weighing. In the first weighing, we know all these 6 coins are equal, because the scale will remain equal, balanced. So the heavier coin is, we know, is in this 2. We can find it from one weighing. And then in the second weighing, we can say which of these is heavier. Do you all agree? Some answers, answers, please. Yes. Yes. Okay. Thank you. So this is the first example. What is the time, by the way? Okay, we are close to 7. Okay, so we are going to look at some more examples like this. Let's try to go till 7:15. Then at the end of that, I have some special exercises. Okay, if you want to stay longer, try some really challenging problems. We can do that. Okay. So let me go to the next question. Okay, there is one more trick that you need to know in GATE. That smart student answered 3 plus 2, that kind of trick, or find x, here it is reply. You need that kind of out of the box thinking. A good example is the problem that I have shared right now. So sum of n terms of the series 4 plus 44 plus 444 plus, okay, it goes on. What is it? We have 4 options, A, B, C, D. Take a minute, come up with your answers and type it in the chat. And it's okay to make mistakes. Just give a sincere attempt, type it in the chat. You are likely to learn better if you have tried it. Okay, as you are trying it out, some student has a question. In the previous question we discussed, instead of 8 coins, the number of coins is 9. Minimum number of toss is still 2. Yes, that is correct. Okay, so let's get to the question on screen. Okay, so someone thinks it's A, someone thinks it's B. And notice we started getting answers pretty fast. The series, of course, one could sit and calculate it, but it will take some amount of time. Okay, it's A, it's B. We have one couple of students saying it's A, couple of students saying it's B. Any other answers? If you actually started calculating this series, that's not the way to go specifically for GATE. Okay, we have 180 minutes, 65 questions. If you are spending more than 3 minutes in a question and you haven't even started, you are taking the wrong approach. Okay, so answer is C. Is that, who is that? Satavisha, thank you. Okay, so couple of students say it's A, some students think it's B, then we have an answer saying it's C. Okay, in this case actually I don't remember what the answer is, but we can figure it out. Okay, or at least I'll tell you how to figure it out. Thank you all for trying. Okay, as I said, this question shouldn't take this long to solve. Okay, so let me give an analogy. Okay, there are some problems like trying to find a key. Okay, you lost it somewhere, you are trying to find it. Okay, you have to search each and every place, you have to derive each and every equation, every line, substitute, do all those things, cancellations, simplifications and all that, find the key, right? Those are one type of problems. Another type of problems, you have a lock, you have 4 keys, you are trying to test which key is the right key. Okay, so this is the second class of problems. Which class of problems are easier? Some answers please. Trying to find a lost key, problem 1. Problem 2, trying to find whether which of the 4 keys is the correct key. Okay, thank you. So we have some answers saying it's the second class, right? That analogy applies to this specific example we are looking at. Okay, if it's taking long, as I said, you are taking the wrong direction. Okay, can we check if these answers are make sense, if they are correct? Can we check if any of these answers could actually make sense for this question? That is like testing if given 4 keys whether each key is correct or not. Okay, let's say we take that as the strategy. How do we check if if any one of these answers is correct? Answers please. Okay, we got a nice answer. Just plug in some, take some n instead of some abstract n, make it very concrete, make it 2. In fact, in this case, make it 1. Substitute n is 1 and see if you get meaningful answers for each of these choices. This is like taking each of these keys and testing if it opens a lock. When n is 1, what is the sum? When n is 1, the sum is 4. Okay, let's see if these options give that answer. For it to be correct, it better do that. Okay, so let's substitute n is 1 here. We have 100 minus 9 minus 1. Okay, so this is like 90 by 81. We don't get 4. Not the correct answer. 10 power n minus 1 is 10 power 0 is 1 minus 9 minus 1. We get a negative number for this nice series. This is not this crazy series like 1 plus 1 by 2 Ramanujan series and all. It's not. It's a very simple series. Okay, we get a negative number. B is wrong. 10 power n plus 1. So 100 minus 9 minus 10. What is this? 81. 81 by 81 get cancelled. What we are left with is 4. Okay, right now this thing satisfies. We need to go check if this also satisfies. If this also satisfies, we will try it for n equal to 2 for these two. Okay, so but we are still at n is 1. So 10 power 1 is 10 minus 9 minus 10. Again a negative number. Okay, so this answer is incorrect. So what is the only option that satisfies a basic simple check that we made? Option C. Okay, so that is the correct answer here. Notice doing this is like you can do it in less than a minute. It's like second. 100 minus 9 minus 1. Okay, so whenever the answer looks like messy, complicated, GATE is not asking you to derive equations of special relativity. No, it's going to be very, very simple. Think out of the box. Think if you can test multiple choice questions. See if you can test each of these answers quickly. Simple cases. 1, 2, 0. Substitute that and see. Okay, thank you. So let's go to the next question. Yes, we get into one of my favorite questions. Again, let's all take a minute and try to answer this. Mr. Smith has 2 children. at least one of them is a boy. What is the probability that both children are boys? Take a minute and type in your answers in the chat, please. Okay, so Madanji thinks is 1 by 2. Okay, thank you. Okay, so we have other answer saying, is it 1 by 4? Okay, good. Okay, so we have, it's either between 1 by 2 or 1 by 4. Most of you are getting into that. Okay, so okay, thanks for trying. So let me again, I don't have the answers on all that. I will have to try. Mr. Smith has 2 children. At least one of them is a boy. What is the probability that both children are boys? So this question, it's a probability question. We are dealing with 2 children, so we can pretty much enumerate all the cases. Okay. See, in general, there are 2 children. It could be a boy boy, boy girl, girl boy, and girl girl. Okay. And what are the constraints in the problem? At least one of them is a boy. Okay. So this is gone. Agree? Girl girl option is gone. What is the probability that both children are boys? Which of these cases satisfy the probability, the condition that we want? BB. Agree? Some answers, please. Okay. So if there are 2 children, there are like in total 4 possible cases. Out of that, one is gone because it says at least one of them is a boy. In all these cases, there is at least one boy. Then there is only one case where both are boys. So the probability we are looking for is 1 by 3. Okay, sir, but aren't boy girl girl boy the same? No, in this case, no, it's not the same. So because if it's like electrons, then you cannot differentiate one electron from the other. What you are saying is correct. In this case, we can differentiate the 2 children. So BG, GB are not the same. Say this is like a younger one, elder one. In this case, this could be the elder person, this could be the younger person, this could be younger person, this could be the elder person. So that difference is there. These 2 conditions are not the same. Okay, thanks. Okay, so do we all agree with this answer? Okay, so this is a very simple probability question that many students get incorrect answers because the simple thing to do is to enumerate the cases and see which of the cases satisfy the conditions in the question. They don't do that. Okay, what is the probability that someone is a boy? Half. What is the probability that 2 children are boy? Half times half, it's 1 by 4. All those kinds of reasoning might happen, but be systematic with probability. Try to enumerate the cases. Okay. Okay. So good question. We have a nice comment. Okay, thank you. So I'm going to give a slightly better question. Okay, I want to know if you all learned it. So I'm going to take this question, rephrase it. Again, Mr. Smith has like, now Mr. Jones has 2 children. The older child is a girl, and what is the probability that both children are girls? Okay, so I might be getting into a trap that I set for myself. Okay, take a minute, please test it. Okay, so we have many students saying it's half. Okay, in this case, let's go ahead and test if it's half. Okay, I think half is correct in this case. So we have this old child and this young child, and in this boy boy girl, girl boy, and girl girl. Okay, so in this, now I enumerated the cases. Here it says, first of all, older child is a girl. So we are left with only two possible cases. Boy boy is not possible, boy girl is not possible. Agreed? Because here the younger child is a girl. These two options are ruled out, not even there in the sample set. So what we are left with is girl boy, girl girl. And what is the probability that both children are girls, which is this particular case? It's 1 out of the two cases that is possible here. So half is the right answer. Okay, fortunately, okay, my answer in the previous question is correct. I thought I made a mistake for a second, but I'm correct. Okay. So with probabilities, the thing to do is many problems, try to enumerate the cases. It's simple. They won't give you like 100 C2, 100 combination, 2 combination, 100 and all that. Mostly they won't give with like 4 or 5 fingers, things like that. That's what they are going to give in the gate. Enumerate the cases. And the major point is, based on minor changes to the question, your answer could be different. And when it comes to probability, your intuition is misleading. What is the probability that, someone is a girl? That depends on whether if there is additional information, she has a sibling, he is a boy, that will change the answer. So be systematic about it. Okay, so half is the correct answer. Most of you got it. Great. Some yes, something. Okay, thank you. And there is one more window missing here. Chat is here. Participants. Okay, I got it. By the way, if I make a mistake, okay, that is fine, because I'm not coming up with written down solutions and all that. We all will discuss and we'll get to the right answer. It might happen. It's fine. I will learn it. I will try to avoid that mistake in the future. But we'll also, always get to consensus and we'll get to the right answer. Okay. So the point is, with these questions, try to read each and every word, in fact sometimes every letter carefully. Okay, so take this as like a tip for the upcoming diagnostic exam. You need to read the question very carefully, and even sometimes letters might make a significant difference. Okay, so let's move from probability. Let's get into some aptitude type of creative kind of questions. If DAM is 4113, what is map? You will learn one of the most important tricks to answer some aptitude question. One important trick, you will learn it in this question. Okay, so if DAM is 4113, what is map? If you have answers, leave it out in the chat. 13116, 13116. Satabisha, are you trying to say something? Okay. We couldn't hear you, that's why I said. Okay, we have, so this 13116 is pretty common. Okay, some student thought it's, okay, yeah. All the answers we have is 13116. Okay, students who don't think it's, who don't know why it's 13116, please raise your hand in the, okay, we have one student. I'll get you here, Mavati. Yeah, sure. So others, I presume you already know how to answer this. Okay, we have one more student. Thank you, Prithvi. Any other students? It's okay to not know. You will know it in a minute. Okay, thank you. So, okay, another student, Shubham Sharma. Okay, thank you. So there is one important trick when it comes to general aptitude. It's very convenient to learn a particular sequence. Okay, memorize it. If you memorize it, you can answer some of these questions very fast. Even if you don't memorize it, you can answer the questions in a reasonable amount of time. And that trick is the position of the alphabets. Okay, yeah, the position of the alphabets. What do I mean by that? Alphabet A is in position 1, alphabet B is in position 2, alphabet Z is in position 26. Okay, so in the previous example we had DAM is 4113, right? So essentially they replaced the alphabet with its corresponding position. So D is 4, A is 1, and then M is 13. This is a very common type of question that's being asked, okay, in aptitudes. So it's nothing out of the blue. They usually ask these type of questions based on position of the alphabets. And you know, just by if you have done some practice, just by looking at 4 and 1, you should like, yeah, this is position of the alphabets. 1 is, I know, is D, A, M. Oh, A is 1, I know this is position of the alphabets. You can get that. Okay, so this is a very, very useful thing to memorize. Even if you don't memorize, you can write the list, you know, in a minute or two and find the positions. Okay, the students who did not know the answer, did you learn it now? So of course the map is, okay, thank you, map is 13 is M, A is 1, and then P is 16. Okay, sometimes they can get tricky with the positions. Instead of this position, they might ask you reverse position. They might say Z is 1, 2 and all that. But that's a possibility, but unlikely. At least know, you know, the basic positions. At least start thinking in this direction. See, at the end of the exam, you know the line of approach, then you have time, you can track the problem. Okay. In national competitions, India level competitions, even a mark could mean a lot of difference. It mean you get a seat or you don't get a seat in a college that you want. Okay, so let's go to the next question. Shubham, did you follow it now? Okay, thanks, Shubham. Okay, so now we'll get, you know, instead of using note, we'll get slightly active. We'll try to reason it out orally, mentally, however you say it. We are going to play a small game. Are you all ready for it? Okay. So I have drawn 3 rectangles. Let's presume they are like 3 boxes. Box A, box B, and box C. And very valuable gift. You know what is a valuable gift? Let's say Dr. Kalam's wings of fire is hidden in one of these boxes. Okay. Now you have to guess and find the correct box. Okay, so all of you just go for a guess and you can type it in chat. We'll get to the actual question in a moment, but right now think of a box. Okay, we have box A. Okay, Shubham thinks is B, A. We are stuck with A or B, okay, for the time being. And just give me a minute, please. Second, please. Yeah, thank you. Okay, so we have some students who guessed A, who guessed B, who guessed C. At this point, okay, there is no difference between A, B, C. All that is fine. Any guess is fine. Okay. Let me just, you know, the students who took B, those students, let's proceed further. Okay. Unfortunately, the slides that follows favor students who chose B. You could have chosen anything at this point, but let's say you all chose B. Okay. B is not the correct answer. Let's say you all chose B. Fine. Agree? At least the students who chose B. Okay. Now, let's look at the students who chose B, and now I tell you one more information. I am going to open one box and say it doesn't have the book. Okay? And there comes the important question that I wanted to pose. Let me make it more explicit. So I am going to open box C and say it doesn't have the book. Fine. Now, the students who guessed B initially, two options for you. Do you want to stick with B or do you want to change to A? Please give your responses in the chat, or even, okay, how many of you want to change? Okay, Madhangi says she wants to stick with B. Okay, how many of you want to stick to B? Say you initially chose B. How many want to stick to B? Raise your hands. Voices are fine. How many of you want to stick to B? Okay, many of you want to stick to B, if that were initial guess. Even after saying, okay, okay, thank you all for answering. Now, how many of you would have changed your mind? Initially I thought B, but given that you said box C doesn't have the book, I'm going to change to A. How many of you would do that? Again, some hands, or some yeses please, yeses or no's please, yeses please. Okay, Prithvi wants to change to A. Okay, any other students? Only one student, seriously? No one else? Some moral support? Okay, I will do what you're doing, Prithvi. I'll go for A. I'll change my mind. I'll go for A. Okay? Okay, and I'm going to do that for the right reasons, because we play this game, say, 1,000 times. Those who change their initial decision, they will win more number of times. Okay? This can be shown using simple probability for today, but I'm going to give an intuition behind why you should change your mind. Are we all in? You want to get some intuition? No, instead of 3 boxes, let's increase the number of boxes. Okay, I think I have like 10 times 4, 40 boxes here. Agreed?
Yes, sir.
Okay, so if for some reason you all chose this one yellow box that I have here, fine?
Yes, sir.
Okay, let's say that was our initial guess. So for some reason, at least say one student guessed it. Okay, initial guess, no information, some random guess. Now, the person who knows what's in each of these boxes, let's say me, I come and open the boxes that don't have the books. I open 38 boxes that don't have the book, and I leave this one box, that one odd one out. Okay. Now I ask you, should you change your mind or you want to stick to your original guess? What would you do?
Change our minds.
Change your mind. Okay. You all get the intuition?
Yeah.
Okay, thank you.
Sir.
So it's hard to see that in 3 case example, but the moment you blow up the number of cases, it's very easy to see. So many number of boxes. I can't have. There is this only one odd box here. I might have made a mistake. I better go for that. Okay, this is what is known as the Monty Hall problem, and the 3-box problem can be shown using simple probability. I'll try to do that. Monty Hall problem. So, in fact, some game shows are based on this logic. Okay. Did you all get a feel for this changing your mind and this with additional information?
Yes, sir.
Okay, great. So, okay, we are 7:25. Okay, I don't have a lot of other problems at this point. If you want to leave, it's fine. But I'm going to proceed further. Okay, those who want to stay longer, and we look at, I think, a couple of more examples. And I have a really, really challenging problem that I want to discuss at the end. Great. Okay, so let me go to the next problem. Okay, this is a simple one. So I have some derivation over here. Where does the first problem occur? Again, go for the answers in the chat.
And then if you have answered in the chat, I will ask you why you think the problem occurs in that line. So we start with A equal to B, we do some manipulations, we end up with 2 equals 1. Where is the problem occurring for the first time? That is the question. In which line? Is it line 1, 2, 3, 4? We have like 6 lines over here. Okay, so we have one answer saying it's in line 4. Okay, any other answers? So how many of you think it's line 4? Please raise your hands. Okay, so okay, now a couple of many think it's line 4. Okay. Okay, Abhishek thinks it's line 4. We also have an explanation in the chat. Okay, Prithvi thinks it's line 2. That is fine. So let's hear from Prithvi and actually learn, why he thought so. Okay, line 4 is the right answer, but let's learn from Prithvi. Prithvi.
So if a square is equal to b square, then how a square is equal to 2? Why is a square is equal to ab, sir? Like,
oh, he multiplies a in both the sides. A
so
equal to b. Start with that. So a times a is a square. Then a times b is ab. So he multiplies, times a at this step.
Yeah, sir. So it should be. Yes, sir.
Okay. So yeah. Okay. Thanks for your guess. That's not the answer here. That's not where the problem is occurring. Okay. So okay, most of you have student guessed it at the beginning. Who is that? Madangi, you want to explain why line 4 is problematic?
Sir, so in the first line itself, they've given A is equal to B. Then when line A minus B will be 0. So we cannot cancel out zeros on both the sides.
Okay, so A equals B implies A minus B is 0. So from this step to this step, we cannot cancel zeros on both the sides. If you cancel, absurd results follow. Thanks, Madangi. And I think many students here actually, I think you thought line 4 is problematic because of that reason. Okay, so let's start simple. How many of you agree that, with the answers that we gave right now? A minus B is 0, so you cannot cancel it at both the sides. Raise hands. Okay, Satabisha, thank you. Okay, slowly all the hands are rising up. Okay, so if A is B, A minus B is 0, you cannot cancel zeros on both the sides. So from 4th to 5th is where the problem is occurring. Okay, this is just just a simple question to sharpen our math logic. Okay, nothing more. Does anyone have any questions or comments at this point? Okay, Monty?
Sir, I didn't understand totally. Like, why, sir? Is it the third step is also like wrong? Like, how did?
Oh, okay. From this step to this step, all he is doing is subtracting minus b square. You can do that, right?
Yes, sir.
A square. Okay. From this step to this step, the thing is he's multiplying a in both the sides. You can multiply by a number. The equation will hold good. Okay. Even if a is 0, it will hold good. From second to third, all he is doing is subtracting by b square. You could do that, right? I can subtract even by zeros, whatever it is, right? I can do that. Then a square minus b square is of course a plus b into a minus b. You take b common out, you get b times a minus b. So till this point, we are good. All these are simple algebraic manipulations. Multiply by a, subtract b square, then write the equivalent algebraic form, take the b out, again equivalent algebraic form. From the 4th to 5th, we cancel a minus b to get a plus b is b. Okay? And we cannot cancel in this example because to be consistent, a is b, we cannot cancel a minus b, which is 0.
Yes, understood, sir.
Thanks. Okay, great. Hemavati, do you still have a question, or is your like hand up for?
No, sir. No, sir. I understood.
Okay, thanks, Hemavati. Okay, so okay, again, this is just to some basic math logics that not a gate question, but sharpening of our math logics. Okay, so let me get to a gate question. How many of you can solve this question right now? Please raise your hand. Value of the integral evaluated over the contour. Mod z is 3 by 2 is dash. We have this very complex looking term. How many of you can answer this? Please raise your hands. Okay, we have some 4-5 students. Okay, so let me rephrase the question. How many of you cannot answer this question? Please raise your hands. Okay, so there are no hands risen. Okay, so all of you can answer this question, right? Okay, thanks. So in the future, we'll try to go deeper into this question, look at all that. But for now, for today, let's do a simple exercise. What are some minor changes I could do here to change the answer? So again, whoever wants to speak, just go for it. If another person is also trying to speak, wait a bit.
Mod z we can change, sir, to 2.
Okay, so if you change mod z to, what do you want to change it to?
2.
Okay, if we change it to mod z, okay, the answer will change. Okay, so what does change of mod z in this case equal to? What is mod z equal to some number mean? Can someone answer that?
Circle.
The radius of the circle of the region, the contour.
Okay, thank you. So this is essentially a condition on z, the complex number, right? This is this is essentially z minus 0 is 2. What it says is from the origin, all the complex numbers that are at a distance 2 form this, or described by this term here, which is essentially circle. Circle with radius 3 by 2 in the original question. If you change the radius of the question, the answer here would change. Agree? And can
Yes,
anyone
sir.
briefly say why the answer would change?
Because the pole will lie with the inside the given contour.
Yes. So again, let me try to add it here. So let's say the original problem, the radius is 3 by 2. We have poles, right? So two singular points. When z is 1, this thing blows up. So z is 1 is problematic, and when z is 2, that is problematic. So the moment you change the radius of the circle for a different circle, both the points need not be inside it. So that will affect what this term is. Okay. So I have a video on how to calculate this integral. Go for it. But for now, recognize if you're changing the contour, will change your result. And for those of you, this is very, very straightforward. I will pose one more question. Can you solve this problem if we have a z minus 1 square times z minus 2 for the original problem? Okay, just try it out. Okay. Again, this is a very, very frequent question from complex numbers, residue theorem, or sometimes the Cauchy integral. Okay, very frequent question. The trap there is minor changes in the question can mean drastic changes in the answers. So you need to know what is what. We'll get to this in one of the classes when we discuss, say, questions in the mock test. But for today, I wanted to give you a tip or a hint. Answer is going to change based on the radius. Fine. Some answers, please.
Yes, sir.
Okay, thank you. So,
Yes, sir.
okay, thank you all. So this is the last question that I have for the day. This is going to take time. Okay, so for those of you who have been with me for so long, thank you very much. I mean, who have been with us for so long. and trying to answer questions. We all learned a lot because you actively participated. The class is like officially over now. What is left is we are going to discuss this one problem for the rest of this. I don't know how long it's going to take. We are going to discuss this problem from now on. So if you want to hang around and crack this, you are welcome to stay. Even if otherwise you think you stay and you think you might learn something, you are welcome to stay. If you want to leave, please. Okay? Good? Some hands or some voices, please.
Yes, sir.
Okay.
Yes, sir.
Does anyone want
Yes,
to
sir.
stay here?
Yes, sir.
Okay, so all of you are here, so I presume you all want to stay, right? Okay. So let's look at this example. I mean, this particular gate question. Did you check the solution that I gave for this question?
Yes.
Okay, so what is this thing called?
Laplace
Okay,
distribution.
so yeah, in the video I said, this is this Laplace distribution. Okay, so this is this Laplace distribution, which is standard. It's a good idea to remember its mean, variance, and all that. But the thing is, Laplace is not all that standard for gate level. Okay, so the standard distributions are perhaps the normal distribution, the Gaussian curve, and perhaps the Poisson distribution. Poisson, exponential, normal, uniform. All other distributions, let me try to think. Most other distributions are not standard for gate level, unless you are in, say, statistics, mathematics, physics, mathematical physics, something like that. They are not standard. So the professors who set the question paper don't expect you to remember what a Laplace distribution is, what its mean and variance are. Having said that, trying to derive the variance for this problem is going to take a lot of time. Okay, so the only option is double integral. Okay, we have some answers in the chat. I'll get to that. So if you actually try to find the variance by its definition, do that. It's going to take a lot of time. If you are using a laptop or something like that, just try to go, find variance of Laplace distribution in YouTube. You'll get videos with pages and pages of derivation. Fine, that's the thing. But in gate, they usually don't ask you questions that take a lot of time, or they don't ask you questions that need some obscure level of memory. Having said that, you can solve this question pretty fast. Okay, we are going to try that in this from right now. I will keep on hinting you with directions that you could approach. I'll think along with you. I thought of a simple way to do it. That also involves memory, but memory from a very well-known subject. Okay, so which is what you are going to do. So, Mihir, I think you are trying to say something like, would you like to say it?
Sir, you said that compare it with 2b square formula.
Okay, can you elaborate a little more?
Sir, like 1 upon 2b is equal to e raised to minus x minus mu minus alpha x, and upon b compare the equations and compare the value
so he
of b.
says yes. So I said compare it with 1 by 2b exponential of minus x minus mu over b. Then compare alphas with b and all that, right? That is the thing. So this is this term correct? Can anyone verify if this is correct? This is a Laplace distribution. I can also do that. Laplace distribution. Okay, so what I wrote there is that's correct. Okay, so yeah, now compare alphas and b. I think alpha would be like 1 over 2, I suppose. Is that correct?
Yes, sir.
Okay, so alpha will be 1 over 2. Then the variance of this Laplace distribution, again from memory or from formula, if you remember it, the variance is 2b square. So the answer here is 2b square. Based on, say, this coefficient is 1 here, compare it with, so 1 over 2b is 1. So b is half, 2 times half square. So that will be 2 times 1 by 4, which is half, right? So yeah, this is the expression I gave on YouTube. But notice this requires you to remember what a Laplace distribution is. Second, it also requires you to know its variance. That is not all that standard. Okay, there is a simpler way to actually derive the variance for this problem in about say 2 to 3 minutes, which is what a typical gate problem should take. Okay, so let's try to figure that way out. And disclaimer, that method also involves some memory, but memory from another very well known set of mathematical tools. Okay, so you want to try it out right now?
Yes, sir.
Okay,
Sure.
great.
Yes, sir.
So let me erase these things. Okay, great. So the first thing is, so a couple of standard ways we can get started with this problem. What are those things? We can try to find what is alpha. Can someone say how we can go ahead and find alpha? Some answers, please. I think you can all turn on your, mics, and even if you want your videos, it's okay.
Uniform distribution total probability is 1.
Uniform distribution total probability is 1. So any probability distribution, the total is 1. Right? So given any PDF, any f of x, who was it? Thanks for the answer. So any f of x, okay, x varies from minus infinity to infinity. You integrate any probability distribution. For it to be a probability, this integral needs to be 1. Okay, so there is one condition, one unknown alpha. We can go ahead and find it. Right? And there are some tricks used here. Let me be again explicit about it. How should e power minus ax look like? So when x is positive, it's e power.
It's symmetric about y-axis.
It's symmetric about y-axis. Thank you. So x less than 0. So this is e power minus alpha x, and this is e power. If x is negative, it's alpha x. Okay. So it's going to drop down symmetrically. It's going to drop down exponentially on both the sides. Okay, this is what you mean by symmetric, right? Okay, so it's going to drop down exponentially on both the sides, and you notice x is negative here, so it's going to drop. It drops. X is positive, but this coefficient is, it's minus alpha x, so it's going to drop. Okay, so now this integral could be written as equals. So because it's symmetric, it's okay to do the integral in one side. Agree?
Yes, sir.
0 to infinity e power minus alpha x dx. Okay, this integral is simple. Can someone please do it along with me? I don't have a derivation or something like that. I might have. Yeah, I think I have. Let's do it along the way. And okay, sorry. So if I replace, there are two such integrals, so it's 2 times this. Okay. So this integral turns out to be, can someone say what this integral turns out to be? Substitute the limits and all that, please calculate it. Okay, so this is 2 times integral of e power minus x by alpha, and then the limits are 0 to infinity. If you plug in x is infinity, this thing goes to 0. If you plug in x is 0, this becomes 1 over alpha. And there's a minus alpha here. So that becomes 2 over alpha. Okay. Yes, Mihir says it's alpha is 2. So this, notice this integral, we started out saying it's all, whatever area under this This curve, because it's a PDF, that should add up to 1. So this implies alpha is 2. Great. We need to know what the Laplace distribution is. We found out what alpha is, right? Till now, it's we can proceed like you can do this integral in a minute. The problematic step is with the variance. Okay. So are you all with me till now?
Yes, sir.
Yes, sir.
Okay. And what is the definition of a variance? It's going to be x minus mu square f of x dx,
Dx.
right? So suddenly to find this variance, we need to know what this mu is, right?
Mean is 0.
We need to know what is mu. Mu is the mean of this particular distribution, which is again the definition. So let's say this is the variance sigma square. In order to find this, we need to know this intermediate term called mu, which is minus infinity to infinity x f of x dx. Agreed? This is where we need to get strategic, and there are shortcuts. First thing, so we need to find mu. Do you all agree?
Yes, sir.
Yes, sir.
Mu can be, the value of mu could be set instantaneously. What is mu?
Mean.
Mean.
Okay, sorry, yeah, mu is mean. What is its value?
0.
Okay, so mu, we have one answer saying it's 0. Do you all agree with that? Okay, how many of you don't agree with mu is 0? Or how many of you don't know why mu is 0 at this point? So you all agree mu is 0? Some answers please.
Yes, sir.
Yes, sir.
Yes, sir.
And can someone explain why mu is 0?
It becomes odd function.
Yeah, odd function, by that you mean it's symmetrical on both the sides, right? So both this curve is symmetrical with respect to this y-axis, right? So when you do the mean, it should be here in this origin because of this symmetry. Using that logic, you can say mu is 0 right away. Symmetric curve, mean is 0. It's going to be at the center. It's not biased either this way or this way. Say if this were a weighing balance, it's symmetric. The mass is equally distributed in this side and this side. So it won't topple this way or that way. CG is going to be in the center. Fine? Agreed?
Yes, sir.
Okay. So notice till now what we have done is we found what alpha is. That's a simple thing. You can do it in less than a minute. Simple e power minus x integral. Okay, you can do that. And then we notice in order to find the variance, we have to know what this mu is. Mu, once you know what this curve is, you can write mu to be 0 instantaneously. So now this integral becomes sigma square is minus infinity to infinity x square f of x dx. So let me write it down. Control Z, e power minus alpha x dx. Agreed?
Yes, sir.
And using the same argument that we used before, we can simplify this integral slightly, which is, this will be like 2 times.
Twice.
Yes.
0 to infinity.
1 second, please. Chat closed. So I'm closing the chat because I don't have space here. So this is twice 0 to infinity, and this thing can become minus alpha x. And this is where, okay, we end up with this right now. Here comes the thing. How do you proceed further? What is the standard way to proceed from here? We can get to this point in a minute and a half, in less than a minute, in fact. Okay, if you are used to doing integrals. So from now on, within a minute or so, we need to say what the variance is. What is the standard way to find this expression?
Integration by parts.
Okay.
Into V.
Yes, this standard way to proceed from here is integration by parts. But if you take integration by parts, you will have to do integration by parts 2 or 3 times. Okay, and there are these 2 limits. It will be a long derivation, which is what is there in YouTube. I'm not going to do that, and I don't suggest you to do that in GATE unless you have tried all problems. This is the only problem, and you have a lot of time left. I would do that. Okay, this is a non-trivial trick, not there in books and all that. So let's just have some, fun trying to get to that shortcut answer. It involves some memory, some mathematical tools, but that's pretty standard. And real pleasure is in introducing the trick. So that's a proper mathematical way of solving a problem, which is why I wanted to discuss. Keep on changing a problem into something that you already know. That's a very, very standard mathematical trick. This is a complex integral. Okay, I mean complex as in like not that z complex. It's like a big integral, messy integral. Can I change it into some integral that I know? If I do that, I am done. That's what a mathematician thinks. That's what I want you to think at this time. Can we somehow change this into some of the things that we are familiar with? Can you all like start guessing? This integral looks like this. Can we somehow do this? Can we somehow do that? Can you have guesses, please? What does it look like? Okay, even if it doesn't look exactly like something you know, does it look similar to something you know? No idea? It's fine not to have an idea, so I'm trying to help you out. Okay, so we have like x square minus e power ax dx. These kind of integrals show up quite often in one of the topics in GATE syllabus. So at some guesses, please. Okay, so let me give you a hint. Okay, what did I say this distribution is?
Laplace.
Laplace distribution. Do you know anything that is there in GATE that looks similar to this integral and that goes by the name Laplace?
Laplace transform.
Laplace transform. Who is that?
Shotobhisha.
Okay, thanks, Adabhisha. So is this Laplace transform? Not really, right?
No.
But can you do any changes here that will make it a Laplace transform? So you do the trick using one of the standard Laplace transforms. You can write down the answer.
X equal to t.
You plug in x as t. That's not a Laplace transform. Let me write. So it's essentially the same integral. So if you substitute x as t, it's t square e power minus at dt 0 to infinity. So this is not a Laplace transform. So sometimes to solve problems, you have to slightly make them complex. But the complex thing, because some mathematical result might be simple. Or while solving a project, you need to, you 3 of you are working on it. One additional friend, creative friend, adding him might simplify things. Though now there are 4 people in the team. Something like that you have to do here, you'll get the Laplace transform.
We have to add some term to make it look like transform.
Yes, great. Is it Anantha Krishnan?
Yes, sir.
Okay, so can we add something here, some term here to make it look like a Laplace transform? Yes, that is a strategy. What should we add here to look like a Laplace transform? First of all, this integral is a constant. Agree? It's a variance. So it's not a function of x, it's a number. It's a constant. So Laplace transform, we have this thing called variable s, right?
Yes.
Can we somehow introduce it and make it disappear at the same time? Okay, let's first introduce it and then make it disappear. Okay, let's do one thing. So this looks similar to Laplace transform. Let's see if we can convert it into a Laplace transform. So let me multiply this by e power minus sx dx. Now what is this term over here, it's Laplace transform of x square e power minus alpha x. Agreed?
Yes, sir.
Agreed, all of you?
Yes, sir.
Yes, sir.
Okay, but now we introduce something, we should make up for it, right? So in Mr. Class, we should
Divided.
make up for it. So we should also make this term disappear. How do you do that? Substitute s is 0. So find this Laplace transform at the value s is 0. When s is 0, this term disappears. 1. Agreed? When s is 0, this term becomes 1. Agreed?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, so now this Laplace transform is a function of s. Evaluate it at s is 0. We make up for the additional thing that we introduced. So we make that vanish. Okay. So what is Laplace transform of x square e power minus ax? Okay, this is one of the standard transforms. You take Laplace transform of x square. You again, there is this scaling. One of the standard properties of Laplace transform. Multiply by e power ax. You get this standard result, right? So let me write it down. So Laplace transform of x square. So Laplace transform of x power n is n factorial by s power n plus 1. Agreed? Standard Laplace transform. So instead of n here, we have 2. So instead of n, we have 2 here. So 2 factorial and s power 3. Fine. But we have this thing multiplying over here. When some exponential term multiplies it, how does it show up in the Laplace transform? One of the properties of Laplace transform. Someone please. This is a very standard property of Laplace transform. I'm not talking about some obscure property. Laplace transform of x square
S
is
plus 1 the whole cube.
s plus, okay, so there is going to be a plus term. In fact, we have e power minus x. So this is going to become s plus alpha whole cube. Okay. So this is one of the properties of Laplace transform. You know the Laplace transform of x square, you multiply that by some exponential, you get that this constant shows up here as an addition. That's all. Fine. And who answered it, by the way? It's s plus in whole cube.
Mir, sir.
Meher. Okay, thanks, Meher. Okay, so x square Laplace transform of that is not all that obscure. It's standard. X power n is pretty standard, and this property of Laplace transform is also standard. Okay. In fact, there are many gate questions based on this one step. Now, just find this value at s is 0. We know what is alpha.
0.5.
That is 0.5. So notice pages and pages of derivation become like fit in here because we did one clever thing, that is some unknown thing came, try to do something into to convert it into a known problem. We know Laplace transforms in and out, so can we somehow first convert it into a Laplace transform? That's my question, line of thought. Okay, I convert it into a Laplace transform, but then I change the original thing, right? Can I make up for it? Substitute s is 0 and I get this answer. I can do this in 2 or 3 minutes. Any of you?
Yes, sir.
Okay. So this, I think, is this is why they asked this problem in the gate, because this problem you can still answer in less than 3 minutes. But the real trick here is making the problem, this conversion here, this trick here. That's a proper mathematical trick. Whenever in mathematics you come across a problem that you do not know, you change it to a problem that you know. This is a very standard mathematical trick. When you come across something that you don't know, think of ways to morph it into a problem that you know. Okay, it doesn't just apply for the gate. You'll be, if you are in biomedical engineering, there are a lot of mathematical model series and all that. Keep this in mind. When you see something very complex, think of ways in which something totally unknown, something that is messy. See if you can make it something that you know very well. Standard mathematical trick, and that's not at all clear. This particular problem, I just happen to. This is my line of thinking. Usually, try to convert things into things that we know, and I happen to find this shortcut. It's not there in YouTube. I did not find it in books and all that, but it is there. I just wanted to, explain my line of thought. Fine. Are you all tired? It's 2 hours. At least answers for this.
Yes, sir. A little.
Okay, so even I am getting a little tired. That's why the story did not come out very well, but that's fine. We have many other attempts to go. Okay, thanks for being with me. I really hope that you learn. We learned many things in this video. Do you have consensus on that? No. Yes or no? Did we learn this class? Did we learn something?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Okay,
Yes,
thank
sir.
you. That's fine. Okay, I'm glad we did that. I also learned many things. Thank you for staying a little longer. I really appreciate your curiosity. It's students like you that drive me, to go beyond my limits. Thank you for that. And then I'll see you. I need to go prepare this notes for tomorrow's class. So I'll see you then. Okay?
Okay.
Okay,
Okay,
sir.
sir.
Okay.
Sir,
Yes. Okay. Yeah. Comments, please. Comments and notes, please.
Yeah, this is Pradeep from Tech at Tamil Nadu. So, as I am working as an assistant professor, it was a great pleasure in seeing you explaining the concepts in a very unique manner and down to detail. So, it makes me to also to implement those ways to teach my student also. So as you have inspired by Kalam, really, I am not saying for the forum like kind of thing. So once I have seen your videos for the past 15 to 20 days. So really I have admired that. I already have sent a mail also regarding that. So really it was a great pleasure in meeting you through online mode. So it was great pleasure, and I hope it will continue in future. And since most of our students, those who are inactive, so your comment was good. So the students are very well beyond our teachers. So it was great interacting with you. And I have a small suggestion. I last class I have missed through online because of some I can't able to join you. So today only I have received the schedules and I have been joining you. So in case in future if you are sending those recording links or recording any videos, it will be more helpful from my side. Like while you are going for gate, I will be having. So whatever the area we are weak, we can go through the videos which you are posting. So if that possible, we are very glad.
Sure, sir. First of all, yeah, thank you very much for your comments. Students, he's a professor, so thank you very much, sir. And yes, in fact, let me tell you what's going on. I forgot to record the screen or record the Zoom meeting. It was on record mode. Then I was waiting for the students to show up. I paused it and then I forgot to record it. I have another camera here in front of me. That also looks like that, turned off. I was going and checking the camera every now and then. So I was saying 1 second please, 1 second please. I was going and checking the camera. That also, I think, turned off. Whatever is left, I'll put it together. I will upload in YouTube. And hopefully in 2 or 3 other meetings, we will properly sort this thing out. We will have a proper setup or a checklist of things to follow so that videos will be recorded and we'll have a copy of it. Best place is YouTube, and I will try to provide it for students to review the classes as well as for students, professors, those who are busy, who cannot attend the classes during the schedule, but off schedule, you want to look at it at your own pace. We are trying to make the videos available. Okay, we are trying to do that, and I have only one request from the students to make this class interactive and all that. I'm using your names, so if your name shows up in the video, please don't get offended. Okay, it's okay. It's all in the learning process. Okay, we are learning, you are learning. The student who is seeing the video is also learning. Nothing personal. If you still think your name, any of that shouldn't show up in YouTube, any of that, send me a message. But this is what is currently going on. Are you okay with that, sir?
Yeah, thank you, sir. Thank you for your
Sure. Okay. Okay. So go and have fun. So I need to go prepare tomorrow's topic, imaging, right? Okay. So yeah, again, let's hope. My point is, each class, all of us should learn something, including me. So a lot of homework goes on behind this. I'll do that. Keep doing that. I like doing that. So I'll see you again.
Bye bye. Thank you, sir.
Okay.
Thank you,
Thank you
sir.
very much. Yeah. Thank you very much. Yeah.
Yes, sir.
Yeah. Thank you.